There's a powder that costs $1 and fixes any crack in any wall permanently in 10 minutes. Not temporarily patches it until next winter, when the freeze-thaw cycle opens it again. Not fills it with a compound that shrinks as it dries and leaves a hairline gap right through the center of the repair that you can see the moment you paint over it permanently. The repair sets harder than the surrounding concrete or masonry in 10 minutes. It bonds to wet surfaces. It expands slightly as it cures instead of shrinking, and it cannot be pulled back out of the crack by the same movement that created the crack in the first place, because its chemistry locks it into the substrate at the molecular level. Every spackle compound, every premixed patching product, every wall repair kit at every home improvement store fails at the same moment, under the same conditions, because every one of them is built on the same chemistry that dries by water evaporation. The crack that was 2 millimeters wide is filled with a compound that becomes 1.8 millimeters wide when it dries. In 6 months, when temperature cycles have worked the surrounding material, the gap opens and the paint cracks, and you're back at the hardware store buying another tube of the product that failed 6 months ago. The global wall repair and patching products market generates over $2 billion in annual revenue from exactly this cycle. The powder that breaks the cycle costs $1 per pound from any masonry supplier. It sets underwater. It expands instead of shrinking. It was used to seal the Thames Tunnel in 1843, when Mark Isambard Brunel needed a material that would set in flowing water and hold against the pressure of the river above it. It was used to seal the foundations of the Brooklyn Bridge in 1870, when the construction engineers needed a repair material that would cure while submerged in the East River bedrock. It is used today in every serious masonry and concrete repair application where a professional needs the repair to outlast the surrounding structure. It is called hydraulic cement. And this is the story of the material the wall repair products industry buried when it realized a permanent fix has no repeat customer. Welcome to Forbidden Camping. Subscribe and hit the bell right now. This channel opens the vaults they spent fortunes locking. Now let me take you back to where this all begins. Let me take you back approximately 2,000 years to the volcanic coastline of the Bay of Naples. Roman engineers building harbor structures, breakwaters, and foundations in the port cities of Puteoli and Misenum made a revolutionary discovery. They found that specific volcanic ash from the Campi Flegrei region, when mixed with lime and seawater, produced a mortar that did not dissolve. It hardened. It grew harder with continued water contact. It could be applied while water was actively flowing across the work surface. We covered the long-term strength development of this Roman pozzolan concrete before, but the hydraulic setting property is about immediate cure in wet conditions. The critical distinction that the modern wall repair products industry has buried is the fundamental difference between drying and setting. Standard spackle, joint compound, and patching plaster dry. They contain water that evaporates as the product cures. When the water leaves, the compound occupies less volume. It shrinks. This is why every conventional wall repair eventually fails. Hydraulic cement does not dry. It sets. The setting reaction is a chemical reaction between calcium silicates and water. Water is not lost. It is consumed and incorporated into the crystal structure. Because no water is lost, there is no shrinkage. The material actually expands slightly as it sets, pressing outward against the walls of the crack, creating a mechanical and chemical bond. British engineer Mark Isambard Brunel, constructing the Thames Tunnel between 1825 and 1843, was the first to systematically document this performance. When sections of the tunnel lining cracked and water began seeping through, Brunel's teams pressed hydraulic cement directly into the active leaks. The cement set in contact with flowing water, sealing the leaks and producing repairs that held the tunnel together for over a century. The Thames Tunnel still carries London Underground trains today through sections repaired with Brunel's hydraulic cement in the 1840s. Now let me show you exactly why this works. Because the chemistry of hydraulic cement versus conventional patching compounds is a vital distinction. It's the single most important distinction in home repair materials science that the construction industry has never had any commercial interest in making clear. Conventional patching compounds, including spackle, lightweight joint compound, and vinyl patching plaster, are all suspension products. They consist of fine calcium carbonate or calcium sulfate particles suspended in a water polymer matrix. When applied to a crack, the water in the suspension evaporates through the surface of the applied material. As water leaves, the particles pack together into a solid mass that is held together by the remaining polymer binder. The drying process produces linear shrinkage of 4 to 8% depending on the specific product formulation. For a 2 millimeter wide crack filled with a compound that shrinks 8%, the cured repair is approximately 1.8 millimeters wide. The remaining 0.2 millimeters of space is distributed at the bond interfaces between the repair and the crack walls. This produces the hairline cracks that follow the perimeter of every conventional wall repair. Temperature cycling widens these interface gaps further as the repair material and the substrate expand and contract at different rates. The repair is a completed failure from the moment it dries, just not yet visible. Hydraulic cement sets through Portland cement hydration, the same chemistry that cures structural concrete. When calcium silicates in the cement powder contact water, they dissolve and the calcium and silicate ions react in solution. These ions precipitate calcium silicate hydrate crystals. These crystals grow and interlock, creating a rigid crystalline matrix. It is chemically bonded to the calcium silicate hydrate crystals in the surrounding concrete or masonry substrate. The bond is not between two different materials at an interface. It is a continuous crystal network that grows without interruption. No shrinkage occurs because no water evaporates. The water is converted into structurally incorporated water in the crystal lattice. The slight expansion during setting, typically 1 to 2%, occurs because crystals occupy more volume than the reactants. This expansion presses the repair material outward against the crack walls, creating compressive contact that reinforces the bond. A study published in the journal Cement and Concrete Research in 2009 compared bond strength and long-term stability. Researchers used standardized concrete crack specimens through 50 thermal cycling events, equivalent to 3 years of outdoor exposure. Hydraulic cement repairs maintained greater than 95% of initial bond strength through all 50 cycles. Final modified patching plaster showed bond failure in 73% of specimens before the completion of the evaluation. Visible crack reformation occurred at repair interfaces in all failed specimens, proving the structural superiority of hydraulic cement. Now, here is where the story takes the turn the construction and repair products industry has always hoped you would never reach. The global wall and surface repair products market generates over $2 billion annually. The residential patching and spackling segment generates approximately $800 million per year in the United States from products that are purchased, applied, and purchased again within 1 to 3 years in a cycle that the product chemistry guarantees. Every dollar of repeat purchase revenue in this category depends on one manufactured belief: that wall cracks are a recurring maintenance problem requiring periodic retreatment rather than a one-time repair problem that can be solved permanently with the correct material. DAP, Red Devil, and USG, the 3 brands that dominate the market, collectively generate hundreds of millions annually from products whose fundamental chemistry ensures they fail before the wall they are applied to fails. The vinyl polymers, acrylic binders, and water suspension formulas that define the category are not engineering limitations. They are product design choices that optimize for ease of sanding, paintability, and low dust when dry. They are also product design choices that optimize for repeat purchase by ensuring the repair fails before the customer's dissatisfaction period begins. A homeowner who applies spackle and paints over it on a Saturday afternoon does not notice the hairline crack reforming through the paint layer for 6 to 12 months. By that time, the connection between the original repair and the current failure is not obvious. They buy another tube. The cycle continues. Hydraulic cement cannot be sanded smooth after setting because its hardness exceeds what sandpaper can work effectively at household scales. It cannot be applied in thin layers over large areas because its rapid set time makes it impractical for large surface finishing work. These are genuine limitations that define its appropriate applications. A crack repair is precisely the application where hydraulic cement's hardness is an advantage rather than a limitation. You do not need to sand a crack repair, you need it to hold. The industry cannot sell hydraulic cement for crack repair because it would eliminate the repeat purchase from the customer who uses it correctly. So it stocks hydraulic cement in the masonry section, labeled for stopping active water leaks, and never mentions it is correct for any crack repair. Where permanence rather than repaintability is the priority, hydraulic cement is the truth the industry keeps hidden. But here is what the construction repair industry's shelf placement strategy cannot suppress. Because professional masonry contractors, structural engineers, and concrete repair specialists have always used hydraulic cement for any crack repair application where the repair needed to last. And their documented specifications are publicly available. The Portland Cement Association publishes technical guidance on concrete repair methodology that specifies hydraulic cement as the preferred material. This is recommended for structural cracks, water infiltration cracks, and any repair where long-term dimensional stability is required. Their guidance is written for engineers and contractors. But it is publicly available, and it says clearly that conventional patching compounds are appropriate for cosmetic repairs to non-structural surfaces. Hydraulic cement is appropriate for any repair where structural continuity or water resistance is required. A structural engineer in Chicago documented a foundation wall repair project in 2018. The client had repaired a recurring crack 5 times over 8 years using various patching compounds, spending approximately $400 in labor and materials on each cycle. The engineer specified hydraulic cement for the repair, applied by the homeowner in 45 minutes at a material cost of only $8. At the 4-year follow-up inspection, The repair was intact, with no visible crack reformation and no water infiltration. The crack had not recurred. A DIY home repair blogger in the Pacific Northwest documented a complete basement waterproofing project in 2021 using hydraulic cement to seal active water leaks. Total material cost was $35. The basement had been treated with crystalline coating twice before at a cost of $600, with water resuming within 2 years. At 18 months after the hydraulic cement treatment, the basement remained dry. Use what the professionals use for a repair that actually lasts. Here is exactly what to do. And I want to be direct about the limitations of hydraulic cement before covering the application. Using it in the wrong situation produces poor results, while using it in the right situation produces results that conventional patching cannot match. Hydraulic cement is the correct material for cracks in concrete foundations, concrete block walls, concrete floors, brick masonry, and stone masonry. It is for any masonry surface where water is actively infiltrating or where long-term structural permanence is required. Hydraulic cement is not the correct material for large area drywall patching, fine surface finishing, over gypsum board, or any repair that requires sanding to a feather edge for painting. For those applications, conventional compounds work acceptably. For crack repair in any masonry surface, hydraulic cement is the only permanent solution. Here's what you need. Number 1, hydraulic cement powder. Available at masonry suppliers and major home improvement stores under brand names like Thoroseal or Quakrite. A 10-pound bag costs $8 to $50 and repairs a significant length of crack. Number 2, clean water. Number 3, a putty knife, trowel, or gloved hand for application. The mixing and application must be fast. This is because hydraulic cement begins setting within 2 to 5 minutes of mixing. Here is the application protocol. Step 1, prepare the crack. Using a cold chisel or a wire brush, clean loose material from the crack. Undercut the edges slightly so the crack is wider at the interior than at the surface. This creates a keyway that locks the repair in place. Step 2, wet the crack. Dampen the interior thoroughly with water. Hydraulic cement works best when the substrate is wet. Step 3, mix a small batch. Mix only the amount you can apply in 90 seconds. Add water until you achieve a stiff putty consistency. The mix should hold its shape when formed into a ball. Do not make it wetter than this. Excess water weakens the final repair strength. Step 4, apply immediately. Press the mixed cement firmly into the crack, packing it tightly with the putty knife or your gloved thumb. For active water leaks, form the mixed cement into a cone shape and hold it pressed into the leak point with your gloved hand. Hold for 3 to 5 minutes until the initial set occurs. The setting generates noticeable heat against your hand. When the material feels rigid and the warmth diminishes, the initial set is complete and the repair will hold without further pressure. Step 5, allow full cure. Do not paint or apply any coating for a minimum of 24 hours. Hydraulic cement achieves 70% of its strength within 24 hours and continues to gain strength over 28 days. Total material cost for repairing a typical basement crack. Approximately $2 in hydraulic cement from a bag you will use for many repairs. Compare that to the $20 tube of caulk that will require replacement within 2 years, or the $600 professional service for the same job. The powder is $1 per pound. The chemistry sets in 10 minutes. The Thames Tunnel has been holding since 1843. Some knowledge does not disappear because it failed. It disappears because the replacement cycle built on its inadequate substitute generates revenue that the permanent solution eliminates. Mark Isambard Brunel, pressing hydraulic cement into active water leaks in the Thames tunnel lining in 1840, was not a home improvement blogger. He was a construction engineer working at the edge of what civil engineering had ever attempted, building a tunnel beneath a tidal river with technology and materials that had never been tested at that scale. He used hydraulic cement because it was the only material that worked in actively wet conditions and set hard enough to hold against the pressure of the Thames above him. The structural engineers who specified it for the Brooklyn Bridge foundations in the 1870s were not making an experimental choice. They were using the material whose performance in water had been documented in every major civil engineering project of the previous half-century. The professional masonry contractor who specifies hydraulic cement for a foundation crack repair today is not doing anything that Brunel did not do in 1840. He is using the material that works for the application, which is also the material whose permanence makes the customer a satisfied one-time repair customer, rather than a recurring revenue source. The consumer who stands in the home improvement store looking at the wall of patching compounds and their dozens of formulations and sizes is being presented with an entire product category built on the chemistry of shrinkage and failure, surrounded by marketing that promises the temporary fix, as if it were the permanent one. Hydraulic cement is in the masonry aisle. It is not in the wall repair aisle. It does not come in a convenient squeeze tube. It does not have a marketing budget. It has the Thames Tunnel and the Brooklyn Bridge, and a cement and concrete research paper confirming that it outperforms conventional patching by 95 to 27% bond retention. The crack in your foundation wall does not know about the patching compound product category. It knows about water pressure and thermal expansion. The hydraulic cement knows the same things. They have been speaking the same language since Roman engineers poured volcanic ash and seawater into the harbor foundations at Puteoli 2,000 years ago. If this vault changed how you look at the crack in your basement wall, you have been patching every 2 years, the water stain reappearing through the paint you applied over the last repair, or the foundation crack your home inspector noted and your contractor quoted $800 to fix. Subscribe, and share this with someone who deserves to know that the repair material used to seal the Thames Tunnel in 1843 cost $1 per pound at the masonry supplier and works in 10 minutes. The next vault opens soon.